Okay, something to think about when you start to blend is when do you want that technology piece and when do you want the students to be interacting and working together or having discussions. So for me, I feel like every lesson has two parts. I feel like there's a discovery part, an exploration and learn, and then there's a solidify and practice part. So a lot of times I just look at my lesson and say, where will the technology serve me best? And I'd like to give you an example where I actually started with discovery in a task and then we went to technology, and one where we did the opposite. We started discovery with technology and solidified with paper. So we'll start with my slope unit. This is one where I found a really great task where students are given staircases and ramps and asked to put them in order of their steepness. Now, they've never seen slope before. This is a brand new concept to them. So it's interesting some of the mistakes that we get. But taking a look at this, a very, very common mistake. They look right away and they see, man, C looks the steepest, but I don't really know how to calculate that steepness, so I'll count the height. And if you count the height on C, you are gonna notice that it goes up 9. And so they're gonna tell me that this has a slope of 9. But the problem is, then they look at D and they'll count that height and they'll say it has a slope of 12, and they're like, wait a minute, that's bigger than 9, and I've already said C is steepest, so they have to really kind of explore and struggle a little bit to be like, well, how am I going to get numerical evidence? My teacher's making me give numerical evidence, and how can I get that? Leads to a great discussion, a great discovery, long story short, but eventually we come to that idea that maybe we better measure 2 directions and find that ratio, and that slope is actually a measurement of rise over run to get that steepness. So once we've had a really good discussion and I feel like they're understanding that really well, then I'll move them to the technology to see if they solidify, because I still know there's going to be a lot more mistakes that we make and some other errors. So I have this Desmos activity that I created here, and the very first screen they see, they're given these similar triangles and they're just asked to tell me if they have the same slope and justify it. As you can see, as you look at those 2 triangles, you may notice that an error that they're going to make right away. We've just talked about how slope is rise over run, and they're going to be really tempted to do what they did with proportionality and just put 1/2 or 4/10 and tell me that they have different slopes. But what's fun about this is students can make their conjectures move through the screens, but then I can take snapshots of their work and present them to the class. And so we'll do that. We'll talk about those, and right away you can see that that first one did in fact say they do not have the same slope. So there's that error I was anticipating and hoping someone would make. And then I have a student who says they do have the same slope because we can see miniature steps. And I really love that they saw those miniature steps. And then we can really discuss how slope has to be a change in Y over a change in X. And there's more things along this where we get to see that ratio over and over, and they're really having to calculate that change in Y over change in X from tables, and eventually they get to graphs where by then it becomes very easy for them to either calculate slope or even draw lines with a given slope. Now when I come to my geometry unit, I actually do it the opposite. I have found that I really like them to discover first. We do a little bit of vocabulary and definitions with them first, but then I just throw them right onto GeoGebra. They draw segments connecting pre-image points to image points. I have them add midpoints, and so I'll say, okay, let's add those midpoints, and sure enough, we'll see that those midpoints are right there on that line of reflection, so that is cutting it in half, and we can talk about what a midpoint is. And then I like them to take some measurements, because what I'm really wanting them to discover here are properties of reflections. And so we'll go ahead and we'll do measurements, and I'll have them measure that angle. And then I'll have them, you said they were midpoint, so we'll have them even take those measurements to verify that indeed are the same. And then they're just asked to write down, so this is a paper task now where they're writing down what they've observed, what they've noticed, what things will stay the same. And then this is where it gets really fun. I let them move the line of reflection, and I ask them, what do you think will stay the same and what do you think will change? And then just let them move this and see what changes and what stays the same, and we can talk about why. So we really get some really great discovery of properties. And then I love them to come back and solidify on paper. So we come back to this task, and now I ask them, doing their best to reflect. Most of them right away get that this distance has to be the same, but it's just a good opportunity to really talk about and solidify. Oftentimes I'll let them pull out a mirror after they've done it and see how close they were, and then try and figure out on their own why they were wrong. But just a really fun, great activity where we get to combine both that technology piece and that hands-on practice so that they can really solidify and understand their learning, deepen their learning. So hope that helps.